let's restart from the apparatus. The apparatus which we need is the accelerated polishing machine. Sir, am I audible now?
Yes.
Okay.
Yeah, you are audible.
So what this accelerated polishing machine do? It basically polish the aggregate with the mutual rubbing between the aggregates and the wheel, due to which so that we can check that after this many revolutions to what extent our aggregates get polished. So, and we need a road wheel. A road wheel is basically a wheel of 45 mm wide and 405 mm dia. Its periphery is flat, on which we stick our aggregate samples so that it gets rubbed between the tire and to know it's the polishing stone value. The rotation of the speed is 320 to 325 rpm. We also need a rubber tiled wheel to create a rubbing action. So it is of 20 centimeter dia and 5 centimeter wide. We need two sieves, 10 mm and 8 mm. After which a single layer of 40 to 50 particles are a rectangular specimen is prepared on which 40 to 50 particles are sticked, and they are 14 in number, which get aligned in the periphery of the wheel. You will get more clear understanding by the figures in the next slide. So let's quickly jump to the figure so that you get better understanding. So what we did, we took this mold, we put aggregates in it, we fill the sand between them, and they get glued with the epoxy. So after the specified duration of the cooling, or means setting period, we get this specimen like that. Here we can see that the aggregates get stick to the mold, and this is like creating a surface of the 40 to 50 aggregates. So what we do, we stick this whole specimen onto the periphery of the wheel, and like this we put 14 samples so that this the periphery of this wheel whole get covered with the aggregates. After that, what we do, we do the accelerated polishing. How we do? Like this. So we put this wheel into the accelerated polishing machine like this. After that, we cover it, and you can see why his near his hand rubber tire is put on this wheel. So you can see that the rubber tire and the aggregates which are sticked on the circumference of this lower wheel are in proper contact with each other. So what we do, we start the machine and it gets rotated at the rate of 320 to 325 revolutions per minute, so that there is a mutual rubbing between those. After what we did, after the specified period, we took out the wheel, we unsticked all the 14 specimens from it, and we check the coefficient of friction between the friction of the aggregate. So how we check? We check it with the help of frictions tester, as in this figure. So how it is done? A specimen is held at the lowest part. Here it is, a specimen holder, and there is a pendulum in between. It is indicated by the arrow. So what we do? We took the pendulum, we raise it to a certain height, and we freely release it. So it will pass pass by just touching the surface of the aggregate, and it will go in the opposite direction. While going to the opposite direction, it will hit the pointer which is marked with the arrow. So generally thinking, like by common sense, if the aggregate is very rough, so then the pendulum will not go to a much height as compared to the smooth aggregate where it can go a much higher height. So this value, this pointer points to a specific value which gets converted in the form of coefficient of friction by using this formula, and this coefficient of friction is correlated with the polished stone value. So our codes suggest a minimum polished stone value of 55 for the wearing codes. Now let's move to the aggregate crushing value test. This test, even this test is not used in India or in US, but I'm just giving a brief idea that what is exactly happens in the crushing value test. As the name suggests, it basically tells us the resistance of the aggregates to the crushing. Means how much it can resist before crushing. In a special case, if the crushing value is 30 or higher, so then we do not report it. We do an alternate test known as 10% fine value test, which I will be discussing in the next section. So for crushing value, what we need a compression testing machine which can apply a load on the aggregates. We need two types of cylinders, as we can see from the figures. One is the thin diameter, another one is thick one. So these two cylinders, one is measuring cylinder, another one is the cylinder on which aggregates are put to apply the load. They have different dimension, like the thin one has 11.5 centimeter dia and the thick one has 15 centimeter, and the height is 18 centimeter. We also needing a tamping rod. Till now, we are already understood what is the function of tamping rod, like to distribute evenly distribute the aggregates. They have different sizes depending on the different test, but their application is same. And we need a plunger. Plunger is at the top right, means the rightmost part. It is a plunger is what which we put on the aggregates so that load is applied by the machine. The machine cannot directly apply the load on the aggregates. So we cover it with plunger, then the load is applied. And of course, we need balance and oven. The sieve sizes are the same. Like the material will be passing from the 12.5 mm sieve and it will be retaining on the 10 mm sieve, as we did in the impact and abrasion value test. The loading rate is 4 ton per minute and this test is run for 10 minutes. So a total of 40 ton is applied on the material. After that, it will be extracted. So what we do, we pass the material from 12.5 mm sieve and the material which is retaining on the 10 mm sieve. We weigh the material. We filled in the similar fashion like we did in the impact test. We fill it in 3 layers, with each layers being tempted 25 times. And when it has reached the upper portion, we strike off the extract material with the help of tamping rod. We just roll the tamping rod over it so that the level becomes, the upper level of the aggregate becomes smooth. After that, we weigh the material and we transfer it to the bigger mold. This thinner cylinder is just for specifying the quantity of the aggregate. So we have weighed that quantity and then we have put it in the testing mold. We can call it testing mold in the similar fashion, like in 3 layers and tamping 25 times. After that, we cover the aggregates with the plunger and we applied the loading with the help of compression testing machine. So after a period of 10 minutes, when 40 tons load was applied, the material is then taken out and received from the 2.36 mm sieve. So the aggregate crushing value, the calculation of crushing value is similar to the impact and abrasion. We initially weighed the material before putting it into it, and now we weighed the material which has passed the 2.36 mm sieve, and the ratio of which is known as aggregate crushing value. This is the case for the standard size of aggregates, like for 12.5 and 10 mm. What if we have a non-standard size of aggregates? Code has also taken care of that. They have given some specifications for non-standard size of aggregates too. Like if we have a larger size of aggregate than 12.5 and 10, so we know that the larger size will crush more under the load. So it will give the higher crushing value. Similarly, the smaller will give smaller values. But the relationship between the normal conventional aggregate 12.5 and 10 and the larger aggregates may not be the same for the different type of aggregate. It depends on the nature of the aggregates. Another problem by using the similar arrangements is that larger aggregates may cause the plunger to jam in the cylinder due to its large size. So if we take a small case of, suppose our aggregate is less than 10 mm. So what code did? They have changed the dimension of tamping rod. They have also changed the loading rate. It was a 4 ton per minute in that case, but now it becomes a 1 ton per minute. Also, they have given a separate table. directly taken from the ISO 386 Part 4 crushing strength test. They have taken that if their material, if you see from these figures, these left two columns, there is no provision in this table for 12.5 and 10. So this is only, these all are just non-standard size. So they have given the dimension of the cylinder and the size of sieve for separating fines. Means after doing the test, the sieve from which it has to be sieved to get the crushing value is also different, where depending on the different size of the aggregates. That's how you can calculate the crushing strength for non-standard size also. So as already told you, this if the crushing value strength is 30% or higher, so we go for an alternate test. It is known as 10% fines value test. Let's see what it is. It is applicable to all the aggregates, first of all. Second, what we need, a tamping rod, which is common in every test. We need a balance, we need sieves, we need CTM. These are the prerequisite for in every test. So what is the difference in this? We first received from 12.5 and retained on 10 mm. We tamed it similarly, which we are doing it in the previous test. So I will not be repeating it. So we will weight it, transfer it, put the plunger and apply the load. Up to here, the steps are same. So what makes this different? What makes the 10% fines value well test different from the conventional crushing test? What we do in that test, what we do, we applied at the rate of 4 tons per minute, and then we stop it after 10 minutes. Here it is not. Here the load which we applied is not fixed. It is dependent on your aggregate. How? We applied a uniform rate so that the plunger gets depressed. We applied for 10 minutes. So it depends on the type of aggregate. If you have round or partially round aggregates like this in the figure, then you will apply a load. The load magnitude should be such that in 10 minutes of time, the plunger should penetrate up to 15 mm. Second, if you have different type of aggregate, so it will have different action under the load. So for crushed aggregate like this, it should penetrate about 20 mm. And in the out of the box case, like if we have this type of honeycombed aggregate, like expanded shales and slags, so for that the limit is 24 mm. So these figures are for representation purpose. They may vary depending on the rounding or honeycombing. So what we do, we apply a load such that in 10 minutes of time, the penetration should be 15 mm for round aggregate, 20 mm for crust, and 24 mm for honeycomb aggregates. We do this. Then after getting this much of penetration, we taken out the material. We sieved it through the 2.36 mm sieve, and then we weighed it by the similar. In the numerator will be the material passing the 2.36 mm sieve, and the denominator will be the total material. So this is the special case. What happens? Normally this value falls within the range of 7.5 to 12.5. They have given these penetration values on the basis of this. There's the final value will be between the 7.5 to 12.5. But what happens if it is not? What if it is 6? What if it is 14? Then what we do? I told you, if you remember, that the load is not fixed here. We will be doing it as per the condition. So if it is not coming from between 7.5 to 12.5, then we will change the load such that the crushing value should come between 7.5 to 12.5. Then we calculate the load required for 10% fines by using this formula. That is 14x divided by y plus 4, where x is the load in tons and y is the percentage fine. What percentage fine? We are getting 7.5 to 12.5, but we must be getting some value like 8, 9, 10, 11. So that value is y. So I would like you to kindly note this formula, because we will be having a short numerical on it in 30 seconds. So kindly note this formula, and you can ask any doubt about this. Shall I start the numerical? Okay. I'm assuming that all of you have noted or took a screenshot, whatever you like. So there is a simple numerical based on this so that you get better understanding of that. The question is, we took a normal crust aggregate, like in the second figure. I have showed 3 circular figures. We do it the crushing value test. It was found to be 35%. So the crushing value will not be the appropriate test. So we will do what? 10% fine test. So how we did it? We took the 2050 grams of the sample. We do the testing at the rate of 2.5 tons per minute up to 10 minutes for the penetration of 20 mm. Since it was a normal crust aggregate, so penetration will be 20 mm. So we took 2050 grams of sample and at the rate of 2.5 tons per minute for 10 minutes. So after the test, the material passing the 2.36 mmC was found to be 246 gram. So you have to calculate the required load for 10% fines. So I hope you understand the question. If there is any doubt, you can ask me. So I am giving you 5 to 10 minutes. So 5 minutes are sufficient, but you can take 1 or 2 minutes more to calculate it. I want at least 2 to 3 people to solve it and give me the correct answer. People who are in the field or are not accessible to pen and paper may not do this, but people who have accessible, they can at least try. It is not your test but you can try. Then I will be also explaining the solution of this.
Sir, 21.875.
Wow, very good. Anyone else getting the similar result?
Sir, is it 14 into X or 14 plus X, sir?
It's 14 into X.
Okay, thank
you. We have few hands raised. Can you ask them?
Sir.
Do they have any question?
Okay, sir. Actually, it was a slideshow mode. I didn't see.
Yeah, I can understand that thing.
Okay.
Ajay Kumarji, do you have any question? Your hand raise is there.
हेलो सर.
Yes sir.
ऐसा कुछ नहीं है सर, हम यहाँ नए खास करके आए हैं. ऐसे हमारे यहाँ से ब्रिज का काम ज्यादा होता था सर, लेकिन PM-GSY का भी रोड हम लोग कर रहे हैं, जो आपके द्वारा बताया जा रहा है सर, गंभीरता से हम सुन भी रहे हैं, उसको नोट भी करते जा रहे हैं कुछ टेक्निकल पॉइंट.
जी सर.
एक्चुअली आपका इसमें एक फीचर होता है गूगल मीट में कि जिसमें आप अपना हाथ खड़ा कर सकते हैं, तो वो आपका जिसमें फीचर होता है, तो वो इसका मतलब ये होता है कि आप कुछ पूछना चाह रहे हैं.
जी नहीं, मैंने हम वही सर सुन रहे हैं सर, शुरू सवेरे से ही
आवाज फ्लक्चुएट हो रही है.
ओके, नो प्रॉब्लम. राजेश त्रिपाठी जी, डू यू हैव एनी क्वेश्चन? I think by mistaken they have raised their hands. So let me make them lower. Okay. So means I think it's a good question. Please go through with the solutions also. I think when you are ending this slideshow, the answer is already visible.
Okay. So okay sir. So I'll quickly tell you the solution. Since the load was applied at the rate of 2.5 tons per minute for 10 minutes, so the load for 20 mm penetration was 2.5 into 10, it was 25 tons. After that, we need the value of percentage of fines, means what we get percent of fines at this load. So the material which gets passed through 2.36 mmC was 246, and the initial weight which we took, it was 2050. So by dividing it, we get the value as 12. So by directly using the formula as 14 into x by y plus 4, we have the x value which was load, it is 25 ton, and the y value which was the percentage of fine, it was 12. So the load required for 10% fines was 21.875 tons. This was the answer. Okay, now let's move to the next test. The next test is the soundness test. Soundness, as the name suggests, it tells us how sound your material is. Sound to what? Sound to the weathering action, the climatic action. So the pavement is subjected to the change in the rainfall and many things which fall on it. So weathering action which can degrade it. So this test tells us how much your aggregate is resistant to this weathering action. What we need for it? We need containers for immersing the aggregates in the solutions we will be preparing. We need temperature regulations, which we already need in all tests, although it may be possible or not at the site. We need a balance, we need oven and reagents. These are the most important things. We have two reagents, sodium sulfate or magnesium sulfate. They both can be used. The difference between them is that magnesium sulfate is at higher degrading action as compared to the sodium sulfate. Suppose if sodium is degrading it at the rate of 50, then magnesium will be doing it at 60 or 70, like arbitrary number. Let's start with this procedure. What we do, the code has provided for different sieve sizes that amount of material which should be taken. So the required test sample is washed, dried and separated into specified size fractions. Then we took a container. We make sodium sulfate or magnesium sulfate solution depending on our will. Then we put the aggregate into this container and we keep it for 16 to 18 hours at room temperature. After keeping it for 16 to 18 hours, what we do, we took out the aggregates and allowed to drain for 15 minutes. Then after that, it is put in the oven at the temperature of 110 degrees Celsius until and unless constant weight is achieved. Constant weight means we are taking it out, checking the weight. Then again we put it, we check the weight. Like this, up to which there is no significant difference between the weights. Up to that, we will dry it. We will do it for a cycle of 5 to 10 cycles. So we are immersing in the solution. We are taking it out, draining it, keeping it oven, taking it out and cooling it. This is one cycle. Then we again do it. This is done to 5 to 10 cycles. After that, what is actually happening? Why are we doing it? Actually, when initially around 40 to 50 years ago, there was a concept. People know that you have also heard about the freezing and thawing. What is freezing and thawing? Quickly tell you. Freezing is when water penetrates inside the aggregates and the temperature is low, that water gets freezed in the form of ice. So we are having ice particles inside, solid ice particles inside the aggregates. But when temperature again increase, this ice gets converted into liquid, due to which it expands. So the aggregate breaks down. But at that time, there were not enough refrigeration facilities so that can simulate these freezing and thawing action. And so this was an alternative test which was used to create the freezing and thawing condition. But it became so popular that now it is used even nowadays due to its simplicity. Because it is even today it is not possible to freeze and thaw at every lab. So we are doing, we are creating this freeze and thaw condition by this alternative means. So how it is done? The sulfate solution penetrates inside the pores of the aggregate. Then after that, when we dry it in oven, the salt in the solution dehydrates and gets stick inside the pores of the aggregate. So when we again rehydrate with the sulfate salt solution, this salt gets expanded due to the expansive force. So when it expands, it creates the similar effects like thawing. So that's how it is creating we are creating the freezing and thawing by not actually doing it. After completing the cycles, the sulfate salt is washed out. How it is washed out? We took the barium chloride solution and we are reacting it. That point up to which it is reacting, it means the sulfate salt is still there. The point at which it stops reacting, that is the point where we stop. The sulfate salt we are sure that sulfate salt is washed out of the sample. After that, we again weight the sample by different sieves, which we did previously when we took the sample. Then we take their weights, and in this test we are checking the weight loss, average weight loss. So as simply lower loss means that you have a good aggregate, more sound aggregate. Specification suggests that a maximum loss of 12% and 18% with sodium sulfate or magnesium salt are used respectively. So I already told you that the degrading action of magnesium sulfate was higher, due to which we can see that the higher tolerance of the loss is allowed in case of magnesium sulfate, that's 18% as compared to sodium sulfate, which was 12%. Here comes another very important topic, specific gravity. Specific gravity is, we are not interacting for a longer period of time. Someone please tell me what is specific gravity. Simple definition.
Density of fluid divided by density of standard fluid.
Okay, okay. Suppose the density of standard fluid is 1.
I guess we take water for the standard fluid, I guess.
Yeah, it is 1. We already take. So please, density of that fluid, you have to again bifurcate it in the form of weight and volume. Okay, let me start it. It is the ratio of weight of a unit volume of material to the weight of an equal volume of water. Suppose we have a material which is occupying some volume. So the weight of the water which will occupy the same volume, it is known as the specific gravity of the material. There are two major types of specific gravity. First one is the bulk specific gravity. What is bulk specific gravity? Here the weight will be the solid aggregate particle. Of course, the voids won't have any weight. The thing which changes is the volume. So in this, we are considering the volume of the solid particle, means our aggregate. We are considering including it the impermeable voids. There are some surface voids on it, in which water won't fill out. So we are considering it in the volume of the solid particle. So which water is getting penetrated. So it is basically, if we see in this figure, the aggregate solid part, and these are the voids in which water is able to penetrate, but there are some surface voids in which water won't be able to penetrate. So we are taking bulk specific gravity is the ratio of weight of that material, okay, divided by the volume. Which volume? The solid part, including the voids which is on the surface, and the voids in which water is getting accumulated. This is the bulk specific gravity. There is another term called apparent specific gravity. The difference is that it only considered the voids which are surface void. It is not considering the voids which is penetrated by the water. Mathematically, as I told you, bulk specific gravity is the weight of dry aggregates divided by volume of aggregates plus surface void. But apparent specific gravity is the weight of dry aggregates divided by volume of aggregates. There are no surface voids. So let's start with the specific gravity test of the aggregates. You have been familiar with this test by seeing this wire basket only. These are the tests which is used for if your aggregate is greater than 10 mm. We use the wire basket method to calculate the specific gravity of these aggregates. So what we need O1 valence, which is common in all the tests. We need a wire basket, which is the highlight of this test. It is a basket made of wire which has 6.3 mm mesh size. So that's why this test is generally recommended for greater than 10 mm material, because if we do it for less than 10 mm material, there are maybe some material which is less than 6.3 mm mesh, 6.3 mm size. So due to which they can pass through those mesh sizes, and then there will be an error in the calculation. So this method is for greater than 10 mm. We need a container on which it is suspended. We need a dry, soft, absorbent cloth. So this is just to make the sample surface dry. I will be explaining how will we do it. We retrace the sample weight is approximate 2 kg. Let's start with the procedure. What we do? We take clean and dry aggregates. We put in the basket, and this basket is lowered and immersed in the distilled water at a temperature. This means it is the basic range of the room temperature, which is throughout the India it changes. The top of the bucket should be submerged in the water at least 5 centimeters, so that we are sure that however full the basket is filled with aggregates, it should be submerged inside the water. Then we take its weight, and there are some precautions, like when we put the basket in the water, we like jolt it. Jolt means we are making it up and down, so that the air which get trapped inside the meshes get trapped out. It is done by doing it 25 times. So we put aggregates inside the basket, inside the water, and we left it for 24 hours such that the aggregates become saturated. After that, what we did, we also take the weight of empty basket after jolting in water, so that the difference between those will give the weight of aggregate in water. So we take the weight of basket and aggregate in water, and the weight of empty basket in water. So the difference between them automatically gives the weight of aggregate in water. After that, what we did, we took out the aggregates, and for 10 minutes we gently dried it by the cloths. So this is my personal question, like suppose you have taken out those aggregates and you have given those absorbent cloths, like you have to dry it by the cloth such that it is saturated surface dry. So how will you decide that it is dried? Will you just put the aggregate and soak it, or will you be just fastly rubbing it with the cloth? How will you decide that it is a saturated surface dry condition? As the name suggests, saturated means we have already taken it for 24 hours. So it is saturated, and surface dry means that we are drying the surface with the help of those cloths. So how you decide that it is saturated surface dry if you have given option? Anyone wants to attempt? Okay, I guess I'm audible. So let's move. What we do? Okay, I'm audible. What we do? We took the aggregate out. We put it on one cloth. We gently soak it. Then we will transfer it to the another cloth. Then we again do it. So when we can also use by passing the warm current, it is recommended in the code, or we can simply switch on the fan. So when we touch the aggregate with the finger and it is not creating any mark of moisture on your finger, so we can say that it is saturated surface dry. The surface is dry and it is saturated. After that, what we did, so we took the aggregates and put it in the oven for 24 hours for at a temperature of 100 to 110, which is the temperature to make it oven dry sample. We have taken 3 weights. Let me summarize it. One, we take the weight in water. Then we take the saturated surface dry weight. Then we took the oven dry weight. So how to calculate the bulk specific gravity? It is, let me like this. Yes. So we see specific gravity, bulk specific gravity is CYB minus A, where C is the weight of aggregate in air, which is oven dried aggregate, divided by we call it SSD weight, saturated surface dry weight, minus weight in water. Apparent specific gravity, the numerator is same. The denominator is, in the bulk specific gravity, we are subtracting weight in water from saturated surface weight. But in the apparent specific gravity, we are subtracting the weight in water with oven dried weight. I already told you in the definition, in the apparent specific gravity, we are not considering the voids which gets filled by the action. So therefore, we are using oven dried weight here. But in the case of specific gravity, bulk specific gravity, we are taking the saturated surface dry weight. We can also calculate the water absorption by the simple formula. This is the when the material is in saturated condition, that is B. So if we subtract it from the oven dried sample, then it will give the water inside the aggregate divided by the original weight. So these are the three formulas for a specific, apparent, and water absorption. So again, I would like you to take a screenshot or note down. So we will be having one more numerical on specific gravity. Okay, I hope you have noted down. So here is the question. The weight of the aggregate submerged in water in wire wasket was 1979 and the weight of empty wasket was 542. When we soak it, the weight becomes 2358, and when we oven dried it, the weight becomes 2324. So you have to calculate these three: bulk specific gravity, apparent specific gravity, and water absorption. So you have 5 minutes. So I'm coming within 5 minutes.
So the specific gravity is 2.52 and apparent specific gravity is 2.62.
And water absorption. Okay, I won't tell you if it is correct or not. Let others try for 2 more minutes.
The water absorption is 14.63.
Okay.
Water absorption is, I guess, 1.46.
Okay. The 14% is definitely not correct because we have a specification for maximum water absorption is 2%.
1.46, sir.
Okay, it's 1.46. Okay.
Sir, water absorption is 1.46% and specific gravity is 2.52 and apparent specific gravity is 2.62.
Okay. I think we have 3 to 4 answers, so we can proceed now. So I'm summarizing the solution for everyone. First, the weight of was how we calculate the saturated weight. We subtract the weight of basket and the aggregates with the weight of basket, which came 1437, which was A in the formula. We have saturated aggregate in air, the weight was 2358, and for oven dried it was 2324. So if we calculate it, the bulk specific gravity was 2.5233. The apparent specific gravity was 2.62, and the water absorption was 1.463. Those who got it right, congratulations. Those who not, you will now get it how it is done, and maybe there was some error. Okay, now let's move to the next test. This was, I told you, since the match size was 6.3 mm, so their stats was recommended for aggregates greater than 10 mm. But for aggregates smaller than, we use another method, which is very popularly known as picnometer method, which is also used in soils and for fine aggregates. It is used for fine aggregates, for less than 10 mm aggregates. Even for fillers, we have different dimensions, but the methodology is same, how it is done. We need a picnometer. What is picnometer? Is basically this bottle, which is conical at the upper end. It is watertight. We need dry soft cloth. So till now you will understand that cloth is just for making it saturated surface dry condition. We need trays to submerge the material for 24 hours soaking period. It was also done, but it was done in basket by submerging in the bucket full of water. Here it is done in the trays, since the material is small in, material is fine in nature. The sample weight is also 1 kg. We need filter paper funnel just to minimize the losses. The material, since it is smaller than 10 mm, it is screened through 10 mm sieve. Then we have a different sample weights recommendations. Like if your material is 10 mm to 4.75 mm, you can take 1 kg material. But if it is finer, then you can do it on 500 gram. What we do, we take a tray, fill it with distilled water, we put the sample, and we left it for 24 hours. Before leaving it for 24 hours, we just mechanically agitate it with the help of any rod or tray, so that's the entrapped air get pass out, and the material is there is the water gets filled between the voids of even the aggregates, and it is left for 24 hours to make it to saturated condition. Then what? Here is the picnometer method. I'm not going to write it. I will summarize it in this figure only. What we first to do, if you see this first one, we take empty weight of this is picnometer, this is weighing balance. We take picnometer, we took the empty weight. Second, this we fill the sample. We took the weight of picnometer plus sample. Then what we do? In that picnometer and sample, we fully filled the remaining part of the picnometer with water, and the fourth one we empty it, and then we only fill the water in the picnometer and take those respective readings. So how it is calculated? Let me first. Yes. Here the A is weight of SSD sample. If we decrease the second weight from first weight, we will be subtracting the weight of picnometer, then we will get the weight of SSD sample. B is the weight of, this is third figure, sample and water. C is the fourth figure, this is only the sample filled with water, and for D is the weight of oven dried sample. So we can calculate it with the help of these formulas. Okay. Suppose now, up to now we have understood two cases, that is material is greater than 10 mm and it is less than. What up to 20 mm or 25 mm we can done it by the wire basket. But suppose the material is so high that it is 37 mm. So that basket method is not appropriate because it's not that very wide. So for that, what we need, we just need a wide mouth glass vessel of 1.5 liter capacity. So we just need a vessel which has a flat ground base and it has tight cover so that it can be water tighted to give a, it can give a virtually watertight fit. So we will do the same thing. We fill it with the sample. Remaining part we will fill it with the water. When we will take the weight of the sample only filled with water like we did in picnometer, but just we need to change the vessel. All other things remain the same, even the calculations. So we can, if we don't have higher aggregates, we can fabricate it in our lab only by taking a simple glass tight jar vessel. Okay, now we come to shape test. First one is the Flakiness Index. What is Flickiness Index? Can anyone tell me? I think we have heard about it before. When we call a particle is flaky, how we decide? I think for sure it is not by visually observing it. It is some mathematical dimension. You've also heard it before. Try to recall. Anyone? Okay. So let's start. When the least dimension of the material, what is the least dimension of any aggregate? It's basically the thickness of the aggregate. When its least dimension is less than 3/5 of their mean dimension, or it is 0.6 times their mean dimension, then we can say that the material is flaky. So how we calculate the mean dimension? First of all, one disclaimer, this test is not applicable to sizes smaller than 6.3 mm because they are so small that we can't even decide which one is least dimension, which one is high dimension. So this is not applicable. As we can see in the figure, it is the thickness gauge. What we do? There is a range of values given on every gauge. Like in the topmost, it is 63 to 50, 50 to 40 as like different sizes. So what is done in the Flakiness test? We took an aggregate, we pass it from these sets of sieves. This size is basically a set of sieves. Suppose we have taken material, we have passed it from 40 mm and it is retained on a 31.5 mm. So what we do, we took that material and a minimum number of 200 pieces is to be taken. So 200 pieces which are passing through 40 mm and retaining through 31.5 mm are taken, and their weight. What is their weight? Then they are being means passed through that gauge. This third gauge, 40 to 31.5. They are passed through that gauge such that if they passes through that gauge, it means the particle is flaky. Means its least dimension is at least 6.6 times less than the mean dimension. So then we can say that the particle is flaky. So after these 200 pieces, the number of particles which passing through that gauge, the weight of those material divided by the total weight is known as the Flickiness Index. Similarly, the Elongation Index. Its definition is when your greatest dimension. What is the greatest dimension? Must be length. When your length is 1 4/5, yani 1.8 times the mean dimension. How we decide the mean dimension? Similarly, in the thickness gauge, there was a gap through which material is passed. Here we have seen these are vertical points. So these are the similarly same readings are given like 40 to 31.5, 30 to 22 like this. So what we do, we pass the material from their longest dimension, and we try to pass it from these two vertical states. If the material passes through it, then it is not elongated. If we recall the flakiness test, if the material passes through the thickness gauge, it was flaky. But if it is not passed through these two vertical posts, means that the material is elongated. It is so elongated that it is not even able to pass between those vertical posts. So that's how we cover it. Similar test is done. It is also not applicable to size smaller than 6.3 mm. In this same 200 pieces are taken. It is get passed. The materials which are not passed is the difference are weight and divided by the total weight. Then it will tell the elongation index. This is how I tell you. Suppose if we see the first one, your material is passing the 63 mmc and retaining on the 50 mmc. Then how you calculate thickness? We just take the mean of both 63 plus 50 by 2. We multiply it by 0.6 times. Then it will get the mean dimension. This is the thickness of the thickness gauge which I have shown you. That is how it is calculated. In case of elongation, it is multiplied by 1.8 times. And there is a provision in code to calculate the combined flakiness and elongation test. How it is? I have told you how to calculate flakiness index and how to tell you elongation. What we have to calculate, we have to report it in a